Well, good morning, everyone, and I'd like to thank ILSI for inviting me here today. I've worked with them on a number of different projects around the world. I noticed that Mancy's flags missed Australia. You've got a very small office in Melbourne, Australia. So just so that you need to, in case you're looking for an Australian vacation, you should be, anyway. This is our head office in Eagan, Minnesota, the AACC head office. Needless to say, it was in fall when this tree shows all of its glory. At the moment, it's got small green leaves on it. We're just starting to wake up from winter in Minnesota. AACC is a professional organization. Our members are academic, government, and industry. In that way, it's rather a unique combination. It does give us, though, the advantages of talking across all scientific and applied areas. We like most professional organizations, we have an annual meeting. We have a significant publication portfolio. We have two journals, Journal of Cereal Chemistry and Cereal Foods World. Cereal Foods World is where the Don paper was published. We have an approved methods program, a check sample program, and a number of other smaller symposium and training areas. When Mancy and Paul asked me to speak today, I thought, what do I say? How do I pull this together? And in fact, for those of you who've been here throughout the conference, I don't think I'm going to say anything new, but I'm going to try and pull it together in a short period of time and hopefully set a background for the rest of the discussions. I found this particular diagram. It's Jim Petzker and a number of other authors, and I thought it was a nice way to look at what nature is doing to us and what man can do in response. And in fact, while it's not an exact division, those areas up in the green on the top left are really the ones that we really have no control about, whereas the ones in the lower right and the blue are the ones that we can actually perhaps make decisions and impact. I'm going to start, and I'm really just going to walk us around this diagram. If we look at the biological factors, we've got, first of all, susceptible cultivars. Our wheat, our grains are susceptible. And we also have the toxic fungi that are very willing to provide toxins and the combination of the two. Just a list, there's obviously many toxins and many fungi that are available. This list, actually, this one now comes from the Codex documents, and I'm going to try, and I obviously can't cover all of these toxins and all of their impacts, but I'm going to try and just sort of look at the areas like aflatoxin and DON, and in particular DON, because that's the one that we worked on with the paper. Both aflatoxin and DON are very important in the cereals industry in North America. Aflatoxin, mold damage. It does tend, however, to locate itself within the warmer regions, so that here in Canada, for example, the fungus has rather a problem growing, although if they import corn from the US, they'll still have the problem, but it is a warmer region, whereas DON is a cooler region and therefore impacts most of the regions in North America. If we add the environmental factors, and I think this is where the climate change piece comes into things, we're looking at temperature and moisture. We have some other areas, and if I can go backwards. Can I go backwards? Yes. Also in this area are, of course, birds and insects. If we're looking at insects, we do have some more recent solutions with the GMOs. This a particular stack is a corn stack, which provides insect resistance. So if we can get some insect resistance, then we have some resistance to fungi. But I don't know how much or how many of you are experts in climate change, but I tend to look at pictures like this and I glaze over a little bit. There's too much information. So I'm going to try and work from it from just a couple of directions. I'm going to look at temperature and I'm going to look at moisture, because these obviously impact our growing and our opportunities. And I just want to point out, for those of you who, perhaps those of you who are in Winnipeg, Winnipeg has a world conservation area for polar bears. And if you've got some time, go out to the Winnipeg Zoo and you'll actually see a wonderful polar bear exhibit. If you don't have enough time to go out to the zoo, then walk down past the legislature building, and on the lawn between the building and the river, they have some large life-size versions of polar bears. So you'll get a bit of a view there. Temperature and precipitation. We're told that temperature is increasing. We're told that precipitation ranges are changing. This is an anomalies graph. It, I think, goes back to about 1903. This monitor is just far enough away, it's outside my vision, so I'm seeing a nice blur there. So if the graph goes up, it means it's a change over the average before that. So I think it's pretty definite evidence that temperature is increasing. This was the chart I pulled off that was February of this year, so it's an ongoing trend. If we look at a global map, this is actually increases over average, and obviously some places that are marked in blue are going down a little bit, but the rest of the places, and particularly where I spend a good part of my time over here in the lower right-hand corner, are definitely going up, and we're beginning to wonder what happened to winter. This is a very recent paper. It's a model looking at what would be the impact of increasing temperature in Europe on aflatoxin. If you look at the left-hand side, that's the current distribution of aflatoxin. Now remember, this is a model, so this is predicted. But the one in the middle, I think, is the one that's quite interesting. It's the 2-degree prediction, and already temperature is up at about 1.5 degrees. We're in that sort of range. So those of you who live in Italy and France and Germany might expect to see more opportunity for these toxins. So there are a number of studies like this. This is a very recent one, published, I think it's April of this year, so very recent. If we look at precipitation, and in this case I've just pulled the US map, of course you can find similar maps to this for most parts of the world, but if you look at this map and follow the center section, those are our river valleys. That's the Red River that comes north here to Winnipeg. The red dot is Winnipeg, just to place yourself on this map. And if you go down further south, we're going down the Mississippi River. So these are our agricultural areas, very strong agricultural areas. And those are the darker areas are greater than 15% increase in precipitation. And these are real numbers, and in fact it's the averages compared from the last 20 years, or say 1990 to 2012, so that's a 20-year period over the 60 years prior. So they're averages over the previous one. So these are not this year versus last year, they are average trends that we're looking at. And if you look at the global situation, this is a global drought map, and in fact if you overlay the current drought situation, you'll see that the fuss in Brazil is quite obvious, that they've got very extreme droughts. We have extreme droughts at the moment in Queensland and in Western Australia. The data associated with this, which is just recently been all pulled together onto one website. So if you're looking for this sort of data, the ncdc.noaa.gov, which is a US website, has pulled all of this information into the one location. And April 2016 was the warmest April since records began. So I think that sort of sets the stage that that's where we're at. So back to my diagram, and I've talked about the environmental factors, the impact of climate change. So what can we do about that? What is man doing? And this is where we come into the harvesting area and then the storage. And at this point, we do have a toolbox. We have a list of activities that can be applied to the management of crops and to the management of the grain or seeds that are harvested. And just to look at this toolbox and how effective it is, and you'll find this in much more detail in the paper. We've heard people talk about weather forecasting. Weather forecasting has certainly improved over the last 30, 40 years. The metrology departments have improved the ability to forecast, maybe not on a local state. You know, they're not going to guarantee that it's going to be sunny all day tomorrow in Winnipeg. But on an average point of view, the forecasting has improved, and that translates into better information in the farmer forecasting areas. We hear everyone talking about making things accessible through the web or with tools that are handheld, the smartphone technologies. We know that there is more research going on in fungicides and the management and use of fungicides, and in fact, combining the forecasting and the use of fungicides. There are new cultivars. We've heard earlier this week about some of the work that's gone on in the scab initiative. The challenge there is often to get the farmers to accept the new cultivars if they're not matched with productivity gains and yield. So there's a tradition there that while we have many farmers who are very, very proactive globally, farmers are looking to run a business, to be proactive, but to have them move off the things that they're familiar with into new cultivars that may not be as familiar is a challenge, and I understand that there's efforts going on in education. So that's another area where we can impact our interactions. In North America, we do have the advantage that if we have infestations in certain areas, we can source from alternate growing areas. That adds cost to the supply chain because you've got greater transport costs, but it's a managed thing. And in fact, most of the large food producers and growing areas in North America have staff who are responsible for these things and who have become experts. It's not always the situation in other parts of the world, and I think you're going to hear a little bit about that in some of the other discussions. It doesn't matter what we do with respect to what the environment does to us or what the farmer or the food producers are doing in terms of managing. We need good information about how effective we've been, and at all stages we need good detection technologies. To do any of it, and I've heard others say earlier, we actually need incentives. And in fact, these are just a couple of the incentives that can sit there if we've got a safety issue. We have government regulations. In the US, the FDA has an action level on aflatoxin. They only, the level is advice with respect to deoxynivalenol. And I've in fact just dropped in the codex, which was decided April of last year. These are incentives that give us some, give us basis and reasons to push back on the producers to have them follow perhaps better practices or improved practices. It's not useful to have data unless you know that the data is quality data, that it's been validated. We've heard a number of people this week talk about sampling. In fact, there was a full day on how important having appropriate sampling protocols are. I would just say that it's wonderful to hear all of these new or improved or have folks tell us how we should do sampling. It's another thing to actually see them implemented. And that's something that I think is equally important. If the protocol says take 3 samples and the people implementing it take 1, then you may as well have just taken the top of the bucket. So it's very important to have good protocols, but also to have protocols that can be implemented and managed effectively. because if you don't, then you may as well toss the coin and positive or negative, and look at your chance. And if you don't have the right sample size, then in this particular example, this is an 800 kernel, it's positive or negative, you've only got a 50% chance of being right, which is of course your heads or tails. So it's not much different. You've got to have a test. You need to have a test that's validated. I think one of the advantages that we have in the area of mycotoxins is that there are many test kit companies who've put a lot of effort into developing robust and valid methods. There are, of course, the most sophisticated methods, but as most of the effort is out in the field, it's important to have rapid kits and kits that are validated. In the US, we have an extra level where the US FDA actually they verify the kits. They don't validate them. They verify that the kits perform per the instructions. So I think it's important to have both sampling and testing, and we're fortunate in that regard. And that brings me back to the paper. You'll find all of these things covered to some extent in the paper. It's an open access paper. You'll find it at the AACC website. And I should acknowledge that the original idea for the paper came from the North American Millers Association. Mind you, they were nudged by the activities at Codex to pay attention. And they not only supplied data from among their members, so it was access to commercial data that we normally wouldn't see, and most of the major grain handling groups, they provided funding for this paper. Others have said that there was a long list of authors, and I'm not going to try and go through them, but it has been an absolute delight this week to find probably half of the authors are here, and some of them are in the audience today. So I certainly acknowledge their support. And I'm going to leave you with this. I find this quite a wonderful picture. It's actually precipitation. It's a global precipitation. It's actually a model. But this model exactly overlaps the precipitation recording on this day. And it's, I think, an indicator of how far the modeling systems have come, and how far the tools have come that we can use in managing. So with that, I think I'm finished, and that's, I hope, giving you some things to think about as we move forward in the rest of the presentations. Thanks.